All right, so in the previous section, we learned how if we know what one of the zeros is, then we can use the factor theorem to help us divide out that factor and hopefully get something that's left. Well, that works really great if they tell you what one of the zeros is, but what if this is not a problem from a textbook? What if this is something that you're trying to figure out and you don't know what any of the zeros are? How can we attack this then? Well, that's what we're going to try to answer in this section. So the first one is the rational zero theorem. And what this does is this helps us narrow down what our possible rational zeros might be. Now, these are just the contenders, but it takes us from looking at all of infinity down to a much shorter list. So if you have our function, then what we look at is we look at P over Q, all the possible ratios of P over Q, where P is a factor of the constant term and Q is a factor of the leading coefficient. Well, what the heck does that mean? Here's how we're going to set this up. We want to list all of the possible rational zeros of f of x. So we want to look at the factors of the constant term, which in this case is 4. So all of the p's are going to come from 4. And the factors of the leading coefficient. Well, the leading coefficient is -1. That's where all of the q's are going to come from. Now, let's start with kind of a list of what these are. All the possible factors of 4. What are the things that go into 4? Well, 1 goes into 4, 2 goes into 4, and 4 goes into 4. But if the positives go in, the negatives do also. So we always want to consider plus or minus each of those factors, okay? And then we want to look at the factors of -1. Well, the only things that go into -1 are +1 and -1. And so now to come up with our list, we need an exhaustive list of all the possible combinations. So I kind of start by working one at a time. +1 divided by +1 is 1. +1 divided by -1 is -1, and so on. But no matter what I do there, if I take plus or minus 1 divided by plus or minus 1, I'm going to get either a +1 or a -1. Then I'm going to look at 2 divided by 1. That's going to give me plus or minus 2. And I'm going to look at 4 divided by 1. That's going to give me plus or minus 4. Those are all the combinations. So these are my only possible rational zeros. So what does that do for us? Well, instead of guessing at what factors could possibly go into this function, I've narrowed it down to only 6 possibilities. Yes, I might have to do a little bit of guess and check, but instead of guessing blindly and infinitely many times, I only need to guess x plus 1, x minus 1, x plus 2, x minus 2, x plus 4, x minus 4. We've just narrowed it down significantly. Let's look at number 2. Again, we're going to look at the factors of P, which is going to be the last number. So the factors of 3 are going to be plus or minus 1 and plus or minus 3 over, now our Q's come from the factors of 4. Well, we just did those, plus or minus 1, plus or minus 2, plus or minus 4. Now this is a little bit trickier when we want to list these out, okay? So I always work with one denominator at a time. So let's go down the list. 1 divided by 1, that's plus or minus 1. 3 divided by 1, that's plus or minus 3. Now move on to the next denominator and do it again. 1 divided by 2, that's going to be plus or minus 1/2. And 3 divided by 2 is going to be plus or minus 3/2. And then we'll do the exact same thing with the last one. 1 divided by 4 is going to be plus or minus 1/4. And 3 divided by 4 is going to be plus or minus 3/4. So we have a total of 2, 4, 6, 8, 10, 12 possible rational zeros. Now again, 12 is a lot to guess, but it's a lot less than infinitely many choices and randomly guessing in the dark. Okay. So here's how we will use this, and this is where you're going to need the assistance of a graphing calculator. Otherwise, you're just going to be guessing and checking until you find one that works. So we want to always start by finding the possible rational zeros, because they're not going to give you one to start with anymore. You're going to use trial and error with synthetic division to find a factor that works. How do you know it works? The remainder is 0. That's what we are searching for, okay? Now, we can use a graphing calculator to help with this, because if it is a 0, if it is a factor, we are looking for x-intercepts if we look at the graph. Once we find one that seems like it works, we need to verify that by dividing, and then we can continue on with the process we did before, okay? So we want to start by looking at our possible rational zeros. So for this one, they're all going to be over plus or minus 1, so that makes it a little bit nicer. We really only have to look at the factors of -6. So the possible ones are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's where we need to guess and check. Now we can just start guessing. Try dividing out +1, try dividing out -1, try 2, try -2, but that might take a little while. So here's what we can do instead. If we go to Desmos, this is the graph we get when we type this in. Now, you can use your graphing calculator. Obviously, you can't use Desmos on a test. I also can't show you my graphing calculator while I'm recording, unfortunately, so Desmos is what we've got. We see that we've got several options. Where it crosses, it looks like this could be -1, it looks like this could be -3, it looks like this could be +2. So any of those three are going to be fine to start with. Now, we can't be certain, because that could also be the square root of 5, or because remember, this is only showing us the rational zeros, nice numbers and fractions. So that value right there could be 0.994 or something. We don't know. So we still have to test it. So let's test +2, just because that seems nice. Okay. We had our possible rational zeros. Mine got erased when I left the page, but they were positive, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So all of our candidates seem good because they were on our list. I'm going to choose +2. Again, that's based off of what I saw on the graph. So when we set this up, we get 1, 2, -5, -6. So let's run this through. 1, 2, 4, 8, 3, 6, 0. Boom. That's how I know that I found one. That's exactly what we want. And so what do we get from here? Well, the factor that 2 would have come from is going to be x minus 2. And then this polynomial here is going to be x squared plus 4x plus 3. And we want to set that all equal to 0 because we're trying to find the zeros. Now this, lucky for us, is factorable. If it was not factorable, we'd have to use the quadratic formula. But lucky for us, we get x minus 2, x plus 1, x plus 3. And so our zeros are -2, -1, -3. And that verifies what we saw on the graph. I'm sorry, I wrote this down wrong. This should be a -2. That's what I had before. So this should be +2 for our 0. +2, -1, -3. Now again, if we go back to our graph, we can verify +2, -1, -3. That's what it looks like on the graph. Now we still have to do the math to verify. You can't just look at the graph and give the answers. That won't be enough. But the math did verify what we predicted based on the graph. All right. So let's try number 4. We want to, again, find all zeros. So pause the video, list out your possible rational zeros. I want you to graph it and decide a good one to test. So come back here in just a moment. All right, here's what the graph looks like. Now, this one to the right of 0 right here doesn't look like a great one to test. The one to the left of 4 doesn't look great. But this one looks like it's probably going to be right at -3. So that's the one that I'm going to start by testing. When we look at our possible rational zeros, the possible zeros would be ±1 and ±3. So -3 is a good one to test because it was on our list. So 1, 7, 11, -3. 1, -3, 4, -12, -1, +3. Yay, we got a 0. Okay, so what do we get? This tells us then, since we use -3, that comes from the factor x plus 3. And then we have x squared plus 4x minus 1 equals 0. Boo to this one because that's not factorable, x squared plus 4x minus 1. That doesn't mean we stop. That just means we have to do something a little bit extra. So if we set this, I'm going to use completing the square. Plus blank equals 1 plus blank. You could use quadratic formula, but I've told you how much I despise the quadratic formula. So I'm going to use completing the square. Remember, we look at the 4 and we say half of 4 is 2 and 2 squared is 4. If I add it to one side, I have to add it to the other. This becomes a perfect square because we built it that way. And when we square root both sides, we get x plus 2 equals plus or minus the square root of 5. So x equals -2 plus or minus the square root of 5. So there's 2 of our solutions. Don't forget that we also have one up here. So the zeros are going to be -3 and then -2 plus or minus the square root of 5. That's a fine answer for me. Remember, my math lab might make you write out the plus and the minus separately. Okay. Number 5, this is the last one we're going to look at, but this one is important for a couple of different reasons. Okay, so we want to start by figuring out all the possible zeros. Well, this is going to be the factors of 24 over the factors of 1. Luckily, that's over 1 because 24 is going to have a lot of factors. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Good thing we don't have to guess and check, because yuck. Okay, so let's look at the graph of this. All right, the graph of this is kind of interesting. It looks almost like a parabola. It's not, because it's not a square, and we can see weird things happen when we get up really high. But it does look like 2 is a solid 0 to test. So let's start there. Let's go back here. We're going to start by dividing out the factor x minus 2 and using +2 as our corner number. Notice we need a 0 in here. So we're going to divide out +2. And we have 1, 0, -6, -8, +24. We should get 0, which hopefully we do. Let's see. 1, 2, 2, 4, -2, -4, -12. This is promising. 0. Ta-da! So what do we have now? X minus 2 times x cubed plus 2x squared minus 2x minus 12. Okay, well that is a cubic, and if it was factorable by grouping, great, but it's not. So we have to do this all over again. Now we know our original list of zeros, all those possible rational zeros that we listed out. Those are still going to be the list that we work from here when we look at this graph. But the problem is, if we go back to that graph, remember we saw the only place that it crossed the x-axis was here at 2. It looked kind of like this. So where do we get another 0? Well, I can tell by looking at the graph that 2, x minus 2, is going to be a factor again. It's going to be a factor at least twice. And how do I know? Because of the behavior of the graph right here. We're kind of coming full circle. This has an even multiplicity because it bounces. So it has to be at least x minus 2 squared. It could be more than that, but it's at least x minus 2 squared, which means x minus 2 should be able to come out of this as well. So we divide it again using 2. This is why knowing your graphs is so important. So we set this up. We're going to run it through again and hope that we get a 0 remainder, which we should. 1, 2, 4, 8, 6, 12, 0. That is great news. So what do we know now? What are our factors? We have the x minus 2 that we started with. That came from right here. Now we have the x minus 2 that came from this one we just divided. And now we have x squared plus 4x plus 6 equals 0. So we can think of this as x minus 2 squared, which is exactly what we knew was going to happen based on the graph, times x squared plus 4x plus 6 equals 0. Unfortunately, this one is not factorable either. So again, you can use completing the square or you can use quadratic formula, but I would love for you to put the video on pause and find the rest of these solutions. You might get an imaginary number, hint, hint. So this is the solution pair that you get when you solve, and you should get the same thing if you do quadratic formula. You might have to do some more simplifying. So our final answer is x equals 2. That came from the x minus 2 factor. And then negative 2 plus or minus I times the square root of 2. So we got a total of 3 distinct zeros, but there's technically 4 because 2 has been a repeat 0. We used it twice. So 2 and negative 2 plus or minus I root 2. That's a total of 4 zeros. All right, I know that was a lot. This is the end. Thanks for sticking with me, and I will see you guys later.